The rocket equation. This is the rocket equation, where the terms have the meanings as shown here. V subscript F is the maximum velocity of a rocket ignoring gravity and drag. VE is the exhaust gas velocity relative to the rocket. M0 is the total mass of the rocket at launch, and MF is the mass of the empty rocket. So M0 minus MF would give the mass of the fuel. So we can increase the maximum velocity of a rocket, VF, by increasing the exhaust velocity of the gases, VE, or having a greater ratio of initial to final mass. This means we must make the rocket itself as light as possible and have it carrying as large a mass of fuel as possible. Here we have a graph of the ratio of initial to final masses of the rocket against delta V, the change in speed of the rocket, given in terms of multiples of exhaust velocity. We get a line something like this. Looking at the ratio of masses being 5, meaning that the rocket itself is 1/5 of the total mass, the fuel being 4/5, or 80% of the total mass, we can get the rocket to a speed of about 1.5 times the exhaust gas velocity. However, looking up here, where the rocket itself is 1/20th of the mass, and the fuel is 19/20th, or 95% of the total mass, we can greatly improve the situation, getting 3 times the exhaust velocity. Here we have the rocket equation again, which we can rearrange to get this expression, allowing us to plot a graph of the ratio of final to initial masses against the actual final velocity of the rocket. We get a line something like this for an exhaust gas velocity of 5 kilometers per second. And now, with the final to initial mass being at 0.2, meaning that the fuel is 80% or 4/5 of the total mass, we can get to around 7 kilometers per second. Whereas if we have the fuel as being 50% of the total mass, giving the ratio of final to initial masses at 0.5, we can get to just around 3 kilometers per second. However, with a higher exhaust gas velocity of around 40 kilometers per second, we get a line something like this. Now, continuing this line along, with the fuel being just 50% of the total mass, we can get to around 26 kilometers per second, a much improved situation. So with a higher exhaust gas velocity, we can carry a bigger payload. We can now have the rocket and any payload, such as satellites, being half the mass of the rocket, the fuel making up the other half.